So here's this lesson on average rate of change. So if you look at this file, hopefully you're able to download it successfully. And if you read the paragraph, it kind of explains what you're supposed to do. You're supposed to use this idea of average rate of change to identify which of these runners, runner A or runner B, is running the fastest. So, just talking about speed, oftentimes we think about speed in terms of car. You have the speed of the car is miles per hour. Or that's the distance over time. Or you can also look at this as the change in the distance, d2 minus d1, over the change in time, t2 minus t1. So it's just saying take the difference of the distances or the difference in the times, and that will tell you how fast you're going, or your speed. This may look familiar. You probably have seen this when you've been dealing with the slope. So let's use this idea of change in distance over change in time, or the average rate of change, or the slope. All three of those is the same in this situation, in terms of answering these questions. So which runner has a faster average speed for the first 9 seconds? If you want to take a second and pause this video right now and try and figure that out, as well as the other questions, that'd be great. So now that you've had a chance to think about these few problems and how you would use this idea of the average rate of change in order to solve them, let's go through it. So runner A runs to the 120 meter mark. That's D2 right there. And then D1 is where he started out, 0. And T2 was 9. And T1 would be 0. Okay? So that's 120 over 9, because 120 minus 0 is just 120, and 9 minus 0 is just 9, which gives us 13.3 meters per second. And if you notice, runner B has the exact same distance at 9 seconds. So we're going to end up with the same thing. So we would say, which runner has a faster average speed? Well, neither of them. They have the same speed. They run the exact same distance in the same exact time interval. So which runner has the faster average speed from 9 to 20 seconds? Well, we calculate runner A. If you look at what I did there, I labeled T1 as 9 and T2 is 20. So I put 20 minus 9 on the bottom. And then runner A at 20 seconds was at 168. And then at 9 seconds, he was at 120. And so, now I just do the algebra. 168 minus 120 is 48 over 11, which is equal to 4.4 meters per second. Runner B has an average rate of change of 213 minus 120, over 20 minus 9. These values are just coming from the table up here. Just the same T2 and minus T1 is the same values. But when runner B is at 20 seconds, he is at 213 meters. And so, here we have, then at 9 seconds, we're at 120 meters. So now you just go ahead and do the algebra. So we get 93 over 11, which is equal to 8.5 meters per second. So therefore, runner B was running faster than runner A, because 8.5 is higher than 4.4. So let's look at the rest of the questions. So the next question asks me between 31 and 20. If you look at the bottom, I've written 31 minus 20, because that's my time interval. And on the top, I'm writing 287 minus 168, because those are the corresponding meters. At 31 seconds, I was at 287, and at 20 seconds, I was at 168. So I'm just doing the algebra to the top and the bottom. That gives us 10.8 meters per second. Now runner B ran 287 minus 213, which comes out to be 6.7 meters per second. So runner A was running faster over that time interval. And hopefully you have this idea down. The average speed, I just take the change in the distance over the change in the time to find it. And you can hopefully transfer that to this next question. I'm going to skip it for the sake of time and just really get to the punchline. Which runner is going to win the race? Well, we can just look back at the graph to see the answer to that question. If we look at the graph, you may be tempted to think runner B is going to win the race because they went further, it looks like. But you have to look at the y-axis, what that means. So it means 400. Who got to 400 meters first? Well, runner B got to 400 meters, if you look down here, at 50 seconds. Whereas runner A, which is the dotted line, that's a pretty awful line. Let me see if I can redraw that slightly better. And let's say it's about 38 seconds. So you can see that runner A won. I mean, he beat runner B by about 12 seconds, which is pretty significant. Being able to run a 38-second 400-meter dash is pretty incredible in of itself. So we would think that the average rate of speed for runner A would be faster than runner B. But let's go ahead and check it out. Okay, so if you look below, I've worked out runner A. He finished the race at 38 seconds, and he started out at 0. And when at 38 seconds, he was at 400, and at 0, he was at 0, which is 400 over 38, which is about 10.5 meters per second. That is hauling right there. And working out the second part, runner B, is 400 over 50, which is about 8 meters per second. So clearly runner A ran faster than runner B, which makes sense, since what we saw in the graph. So let's look at some more examples. So on this one, if you flip your page over to the back of the page, it says to draw a line between the 2 points and to find the average rate of change, or the slope. You'll be able to see that the slope of this line is just 0. So therefore, if we were to do this algebraically, we should get the slope is equal to 0. So let's write out the points first off. This point right here is located at 6, 5, and this point right here, the left side one, is located at 2, 5. So using my y2 minus y1 over x2 minus x1, let's go ahead and label these points. Let's call this x1, this one y1, this one x2, and this one y2. It really doesn't matter what you call x1 and x2 as long as you're consistent, meaning your x1's with your y1 and your x2's with your y2. So y2 is 5, y1 is 5, x2 is 6, and x1 is 2. That leaves us with 0 over 4, which is equal to 0, which is what we assumed would be our average rate of change. So let's look at another problem. So here I can take and draw my line between the two, and I'm trying to find the slope of this line. Another way that a lot of kids did was they counted down 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3. So the slope should be -7 over 3. That's a quicker way of doing this. Let's double check it with our using our points. So this point is located at 0. Oh, by the way, you can pause this anytime if you want to try working this problem ahead of me to make sure that you got it down. This point's located at 0, 4. 0, 4, if I can possibly write that down. And this other point is located at 3, -3. By the way, this interval right here, this is where these values are found in it. So again, labeling x1, y1, and x2, y2. plugging it into the equation, we have negative 3 minus 4 over the top of 3 minus 0. Just y2 minus y1 over x2 minus x1. So that gives us negative 7 on the top. That is a 3, not a 7. Negative 7 on the top over 3, which is what we had down here as well. They match. Cool beans. So let's look at two more examples now. On the next page we have this situation with population growth of, what is it, flower beetles? I have no idea what a flower beetle is. But the first thing it asks us to do is to complete the table below, and it gives us this equation right here. So they tell us first off that we start out with 25 flower beetles, so population at week 0 was 25. And then I just find 25 times 2 to the first power by plugging in week number 1 in, we get 50. And the second week, 25 times 2 squared is 100, and that gives us the next number there. And you may see, and also in the situation it tells us the population doubles every single week. And we said this equation actually does that. It goes 25 to 50 to 100. So the next one's going to be 200, then 400, then 800. So there we go, we have the table figured out. So we're supposed to calculate the average growth rate between weeks 1 and 3. So we do the same thing as before. This week our time is going to be 3 minus 1, and the top is going to be 200 minus 50. And that turns out to give us 75 bugs per week. The next part asks us to calculate the average growth rate for the first 5 weeks. And so we're going to have 5 minus 0 on the bottom, and then 800 minus 25 on the top. That gives us 775 over 5, or 155 B per W, or bugs per week. So which average growth rate is higher? Well, obviously the second one, or the one from weeks 0 to 5. Why do you think it's higher? Well, I'll let you fill that out. So on the next page, and the last problem we're going to look at, is this time it doesn't give us a graph. And so we're going to need to find our x1, y1. I'm going to do it without graphing at all, and just looking at the values. So the value at x sub 1 is negative 3, and the corresponding y value, I don't know. I need to figure that out. And the way I can figure that out is by plugging negative 3 into the equation. So let's go on ahead and do that. If I do 2, so the way I'd write this is f of negative 3. This is evaluating the function at negative 3. To negative 3 plus 1 plus 1. And you can just plug that into your calculator if you want, or if you're going to do it by hand, you end up with 2 to the negative 2 plus 1, or that is also equal to 5 over 4. So the y sub 1 is 5 over 4, or 1.25. To find my x sub 2, y sub 2, I'm going to plug in 2, so f of 2 is equal to 2 to the 2 plus 1 plus 1. And you can work that out, or I'm running out of time, so I'm just going to tell you that it is 9. So now I just put this on y2, y1 minus y1 over x2 minus x1, so 9 minus 5 over 4, over the top of 2 minus negative 3. And I am just about out of time, and so I'll let you just work that out on your own. No, I think I have 20 seconds, I can do it. So this gives us 7.75 on the top, over the top of 5. And I'll have to let you work that out because I don't have a calculator in my hand right now. So 7.75 over 5. Find that, and that goes right there. Thanks for watching.